Maps allow us to map a key to a value. Let's write out an example of how a map works in Golang. So we're going to start with a var, and we're going to call this map M, and we use the term map. And let's map a string to an integer for this first example. So I'm going to map my name, Nick, to an integer such as 5, and we'll print this out. Now I'm going to use a % plus v, which what that will do is it actually prints out the keys and the values in the print statement. And then I'm also going to do a length to show how long the map is. So we'll just do m and len of m. This is so the same built-in function we can use on a slice, we can also use on a map. Okay, now we ran into a problem, assignment to entry in nil map. So this statement here actually creates a nil map that has not been allocated yet. So what we need to do is we need to allocate it at the start. So there's a couple different ways we can allocate the map. We can do it using an assignment, such as m : equals map, and then we just need curly brackets. That's one way to do it. And then we'll run this. So you can see it prints out Nick : 5, meaning Nick maps to 5. Another way we can do this is using the make command. Let's modify this one. You would just say var make. Now this allocates a map the same way this one does. Okay, so the benefit of using make over this command is we can actually specify how big we want the map to be on the first allocation. So if you know you're going to have a very large map, it would make more sense to call the make, let's say, with 1,000. If you know you're going to have 1,000, then it would be to start with this allocation method and then start adding elements to it. Because just like a slice, a map has internal memory that once that internal memory is full, it needs to reallocate and it needs to move elements around for it to handle the next size up. So if you start with this method and then start adding up to 1,000 or even more, it could cause a lot of allocations. So we're going to use this method just for this example. Now, you can map almost any key to a value. So here we're doing a string to an integer. You can even use a struct for the key, or you could use the struct for the value. Let's show an example of using a struct. So I'm going to show a house. Now a house could have bedrooms, bathrooms, and then let's say size for square footage. Okay, and we're also going to use string here, and then I'm just going to say house there. Let's get rid of this just so it looks a little cleaner. Now for my house, I'm going to create a house, and then I can initialize beds for bath to, let's do a size 2,500 square feet. That's a nice size house. Now this is one way to initialize one element here. We could also include the initializer up here. So this is a benefit of using this method. Here you would say Nick, and then you could have the house defined in here. And one shorthand thing you'll notice is that we did not have to use house here. If you actually put house there, our lint check will actually tell us that it's redundant and you don't actually need it, but it's assumed that's the type, since up here we already know the type. So either of these methods work. Let's print this out, see what happens here. Now we have a map that maps Nick to this house here. What happens if we want to change an element within here? Let's access mine. And you might assume you can do a dot operator. Let's say we increased the number of bathrooms to 3. Now we actually get an error here. Cannot assign a struct field. What this actually means is that we are using a type here that is not a pointer or a reference. What happens if we try to capture Nick's house over here? Let's try it. Nick's house. And then let's try to change Nick's house baths to 3. And let's print out our main map, and then also let's print out Nick's house. And let's see what happens. Now you can see in the map we still have beds for baths 2, but in Nick's house it is at 3, so we've increased the size of this one. The reason this happens is because we are using a value here and not a reference. So when we pull out Nick's house from here, it's actually taking a copy of the house and putting it there. So when we modify it, it's not modifying within the map. The way to fix this is we just use a pointer here, and then everything should work correctly. Now, our print statement has changed also because we're actually printing out the memory location of that house pointer. So what we could actually do to verify Nick's house is we could actually take the actual element there and print it. Let's see what happens. So we can see that both the baths and the size are the same. Now, instead of doing it this way, we could actually change this to be dot baths now. And now we don't need that. And that's the same thing. Now let's say we want to delete an element within the map. We just use the delete keyword, and then we give it the map, and then we give it the element that we want to delete. Now we can actually print this back out again. Let's just print out M and then run that. Now we can see that this element is now deleted.